Assalamualaikum and hi. Now I want to introduce my group member. First, Nur Tasnim Safia binti Zulkarnain. Next, Nurul Aisyah binti Ahmad Yusni. After that, Syadatul Irina binti Syahrul Niza. And then, Intan Alicia binti Mak Ayub. Lastly, Nur Dania Husna binti Umar. Definition: addressing mood is the main process of program implementation, is nothing else, just the manipulation of data. We need to know how to identify the source of data, procedure to fetch this data, to process this data, procedure to send this data to the required and allowable destination. The procedure of fetching and sending data between source and destination is carried out by various addressing approach, which one known as addressing modes. The addressing mode in M68000 processor. First, register direct addressing. Second, immediate addressing. Third, absolute data addressing. Fourth, register indirect addressing. Lastly, program counter relative addressing.
Question 1A. Question number 3. Example of a M68K assembly program that perform addition of two numbers using three addressing modes. The equation for this program is 18 plus with 15. It start with start and $1000. The first instruction is move.byte hashtag in a bracket 80 to W1. The instruction is in direct addressing modes. After that, move.byte hashtag 15 to W2. The instruction is direct addressing modes. Last but not least, add.byte W to W2. The instruction is register direct addressing modes and end it with RTS. Question number 4. Examples of M68K assembly program that perform subtraction of two numbers using three addressing modes. The equation for this program is 45 subtract with 36. The program starts with start $2000. The first instruction is move.byte hashtag 45 to D0. The instruction is in direct addressing modes. After that, move.byte hashtag in a bracket 36 to D1. The instruction is direct addressing modes. Last but not least, sub.byte D1 to D0, which is the instruction is register direct modes, and end it with RTS.
Question B. A student learned how logical and arithmetic operations are performed at the assembly level using the Motorola 68000 processor. The instructor has asked him to explain how basic logical instructions work in practice based on figure 1 below using Easy68K simulator. Question 1. Describe every step of the assembly language of figure 1 using Easy68K simulator. The answer is $2000 is the instruction will be stored at memory location 2000H. Move.w hashtag $4AB7 into D1 means move the immediate value in hexadecimal into data register D1. Next, not.w D1 is performs a bitwise NOT, which is first complement operation on the contents of D1. Next, move.w hashtag $5E92 into D3 means move the immediate value into data register D3. Next, or.w D2 into D3 means performs a bitwise OR operation between D2 and D3. D3 keeps the result of OR operation. Next, add.w D2 D3 means adds the value in D2 to D3. It's a word size addition, which is D3 equals to D2 plus D3. Next, sub.w D2 D3 means subtracts the value in D2 from D3. It's also word size subtraction. D3 equals to D3 minus D2. Next, N. N marks the end of the program. It tells the assembler to stop assembling code beyond this point.
Alright, for question 1b2, we are looking at two main types of instruction used in computer system: logical instruction and arithmetic instruction. First, let's talk about logical instruction. These are used to perform logical operation on binary data. That is, data represented in 1 and 0. For example, N gives an output of 1 only when both inputs are 1. Or give an output of 1 if at least one of the input is 1. Exclusive OR give an output of 1 only when the two inputs are different. NOT is used to invert the value, turning 1 into 0 and 0 into 1. Next, we have arithmetic instruction. These are used to perform mathematical operation on data. For example, add is used to add two numbers. Sub is used to subtract. Mulu means multiply, unsigned which multiplies number without considering positive or negative sign. And divu stand for divide, unsigned, which perform division in the same way.
Question 2a is convert the expression below into an assembly language instruction, which 1011111 base 2 multiplied by DA base 16 plus 1234 base 8. This assembly program calculates the expression 1011111 base 2 multiplied by DA base 16 and plus 1234 base 8. It first loads each value into separate registers, which D0, D1 and D2. Then it multiplies the binary and hexadecimal numbers using mulu.l, and finally adds the octal value using add.l. The final result is stored in register D2.
So, the conclusion for our assignment is this assignment comprehensively evaluates a student's foundational knowledge and practical skills in M68K assembly language programming. It focuses on three key areas. First, addressing modes testing theoretical understanding, which is defining, and practical application like writing code for arithmetic operation using various modes. Secondly, instruction set analysis, assessing the ability to trace and describe the function of both logical NOT and OR and arithmetic add and sub. Last but not least, data manipulation, challenging the student to convert between different number systems and translate a complex mathematical expression into a sequence of M68K assembly instructions. Overall, the task requires students to demonstrate their ability to define, analyze, and apply core concepts of M68K programming.